welcome to GDC Classes English. So we are back with our MCQ series in which we are going to have a good conversation with the relevant concepts on the MCQs that we are going to discuss for any pharmacist exam, be it GPAT, be it NIPER, be it MRB, be it RRB, Railway Pharmacist, Telangana DI, UPSC DI, or even AIIMS CRE, right? So this is a all-in-one pack. You will get the questions along with the relevant explanations. So I hope you all are stick with me till the end of the video because we are going to have a productive video this time. Okay, so let's begin with our first question. So here, the first question, the topic that we are going to start here will be the micromeritics and the rheology. All right. So the first question that we have here is that Stokes law. You all have heard about the Stokes law in the sedimentation part. Stokes law cannot be used if the Reynolds number is more than 0, 0.2, 1.2 or 2.2. So those who remember Stokes law equation we have covered in the sedimentation part. Alright. Now this sedimentation part actually is observed where the enricing pipette method, hydrometer method, balance method were discussed. Okay. So this Stokes law equation gives the idea about the velocity of the particle settling, which is directly proportional to the diameter of the particle. That means obviously the larger the diameter, faster will be the settling of the particle with the density difference along with upon 18 eta. So this is a simple equation of the Stokes law, right? Here we have the velocity of the particle settling directly proportional to diameter and the eta, which will be the viscosity. So similar profile is actually achieved when we are talking about the viscosity also, right? So here in the case of the Stokes law equation where we are talking about the Reynolds number also includes a similar kind of equation whereby we have Re is equals to 2 R pi eta upon delta upon eta. So here also you can see a similar relationship in comparison to not pi, it will be V, right? Yes. So the Reynolds number and the viscosity relationship here we also can see. So if it has a value around 0.2, it will indicate the laminar flow, right? It will indicate the laminar flow. Above this, the turbulence will be much higher seen. So Stokes law equation cannot be used if the Reynolds number is more than the 0.2. So for that matter, if you want to keep it in a single word, the Reynolds number value must be less than or equal to 0.2. So it has the laminar flow. Okay, and if it is increased, then it will turn into a turbulent flow. Okay, so I hope it is clear. Option B is the correct answer. Okay, next question. Mercury displacement method is used to determine option A granular density, surface area, granular volume, granular size. Right. So let's eliminate these options for you so that you can all clearly focus on what exactly is to be answered. So in this case, it is very evident if you have a simple knowledge that surface area can be determined by two methods. Number one is the adsorption method. Second one is the air permeability method. Right. So in the adsorption method, what happens? We use a quanta solve. Here we have a gas adsorption method as well, a solute adsorption method as well. So the amount of gas which is adsorbed over the surface of the adsorbent, that is actually found out, right? And the equipment that is used is the quanta solve. The equation that is used is the BET method. Okay, here in the adsorption method, you use quanta solve, right? And the equation is the BET method. This is a very important topic. In the air permeability method, mainly here the 𝘂𝙎𝑐𝑎REMAN equation is used. 𝘂𝙎𝑐𝑎REMAN equation is used. So direct these questions can also be asked. Okay, so mark them important. So now we are only left with the Mercury displacement method, which is determined for the granular density, right? We have true density, bulk density and granular density. So granular density is determined using the mercury displacement method. Okay, option A is correct. Okay, now moving on. Coulter counter method does not give you the information regarding. So for those who do not know, Coulter counter method is for the measurement of the particle volume. Particle size can be measured into multiple parameters. It can be particle intensity, number, size range, or even particle volume. So Coulter counter method is used for the determination of particle volume. Now this method is actually based on the conductivity, right? So generally what happens, we have a beaker here, it contains a conducting liquid, right? So from this apparatus we have a simple orifice here. The conducting liquid is actually passed from this orifice. Obviously there will be electrodes for maintaining the charge. So as soon as the particles will pass from the conducting liquid through this orifice, there will be a change in resistance. Mark my words, these things are really important. As soon as the particle will pass through the orifice, there will be a change in the resistance. This change in the resistance is noted down as a signal and you get the particle volume. So it can actually measure particle up to 4000 particle per second. Such high, such rapid determination, right? So you can see among all methods, this is for the particle volume measurement. Up till 4000 particle can be determined per second. So it does ever mention, it gives an idea about the particle shape? Not at all. It gives the idea about the particle volume, not even about the particle size. So question says of which it does not give the idea. So yes, it does not give the idea of both A and C, neither particle shape nor particle size, but particle volume. Okay, so here we have our correct answer is option D. But if it was like what is asked here, so particle volume would be the nearest correct answer. Okay, next question. Shape factor ratio for is 6 for a spherical particle. So for a particle which is exactly in the form of a sphere, the value is around 6, right? So they are asking for the asymmetric particle. It is a generalized consideration whenever we are comparing the particles, that the particle which is asymmetric in nature is considered to be in the approximate shape of sphere. But no worries, here we have to look at the shape factor ratio. So if for a spherical particle it is 6, for an asymmetrical particle it will be most evidently less than this. Okay, so here you can see the particle shape. If it is like an oblong particle also, then it can be more than 6. But for an considerably put up as asymmetric particle, it will be less than 6. For a complete sphere, it will be considered to be 6. Okay. So here it is a option B as the correct answer. Next question. Next we have porosity of a porous powder can be defined as. So for those who do not know, porosity whenever we are talking about the voids or the gaps. The particles are arranged in a certain manner that they may also have certain gaps between them. The interparticular voids, the interparticular voids, right? So that is actually eliminated. Then you consider as a true density of the particle, right? So here the porosity is what? Porosity gives an idea about the void. So it is nothing but the void volume upon bulk volume. This bulk volume, how it is different from the void volume? Void volume is just the volume of the powder, right? Which is the void, the space, while the bulk volume includes everything. True volume, interparticular voids, intraparticular voids, everything, right? So here we have porosity as void volume upon bulk volume. Okay, right? Next, the average particle size of the powder can be determined by. So in the micromeritics, it is very obvious that it is for the determination of the particle size. We have 4 techniques, although we have sedimentation method, sieving method, we have microscopy technique as well as the Coulter counter method for specifically the particle volume. But for calculating the average particle size, there is a simple equation that is asked in GPAT 2023 also it was asked. So the average particle size is calculated as summation ND P plus F upon summation NDF raised to the power 1 upon P. So now it is on you to guess it which equation is it. For the average particle size calculation, this P is the index related to each particle which can have a value 1, 2 or 3. F is the frequency index having a value 1, 2, 0, 1, 2, 3, right? So this is none other than but our Edmondson equation for the calculation of the particle size, average particle size. If the Anderson apparatus is asked, it is for the particle size measurement. But here, if you know, for the based on the Stokes diameter, it is calculated, not the average particle size. But here, the particle weight is usually taken into consideration, which is converted into particle number. So there are multiple equations by which you can convert it, right? But only average particle size gives you the correct idea. Okay. Then Stokes equation, which is here only based on the sedimentation method, and last we have Huckel's equation, which is not relevant here. So correct answer will be Edmondson equation, option number A. Okay, next question. Granules with rough surface will have high angle of repose, low angle of repose, medium angle of repose, or any value of angle of repose. So if you remember, whenever we are actually evaluating based on the particle flow ability, right? Particle flow characteristics, we have three methods. We have number one, Carr's index method. Number two, we have Hausner ratio. Number third, we have angle of repose. In the angle of repose, the generally formula that is used is equals to theta tan inverse h upon r. Certainly it can be put up as tan theta is equals to h upon r, right? So this h is going to be the height of the pile and this r is going to be the radius of the pile. So for those who still don't know, suppose you have a powder, any powder, let's suppose. So you put up into this funnel, the powder will pass through this funnel and form a heap on the paper, right? So this powder will have a certain height as well as certain radius, right? Even if you want to calculate the diameter, it is fine. Okay, so this is a fixed cone method. Here the heap of the powder which is present here, the height and the radius can be calculated by using a simple scale that you use, right? So here you can put the values and get the value of your angle of repose. So different powders have different angle of repose. If the angle of repose comes out to be around less than 25, then it shows an excellent flow. 25 to 30, it shows a good flow. Then post of to 30 to 35, it shows passable, and more than 38 or even 40, it shows a very poor flow. So different powders can be characterized for their actually angle of repose determination. But one important thing to be kept in mind before answering this, rougher the surface, higher will be the angle of repose. Mark my words, rougher the surface, higher will be angle of repose. Higher the angle of repose, poor the flowability. Higher the angle of repose, poor will be the flowability of the powder. So here granules have rough surface that is directly pointing to a higher angle of repose. Higher angle of repose means it will have a poor flow property. Okay, so option A here is correct without any doubt, right? Option A is correct. Next question. Which of the following apparatus is used to determine the particle size by gravity sedimentation method? So for the particle size determination, we generally use number one, microscopy method, number two, sieving method, third, sedimentation method, fourth, Coulter counter method, which is under the conductivity, right? For the microscopy method, we generally use the optical microscope, right, or electronic microscope. However, the method is quite slow, right? For the sieving method, we have a sieve shaker on which one or the other sieves are stacked upon each other. Third, we have sedimentation method, in which we have mainly three apparatus. We talk about the Anderson apparatus, we talk about the hydrometer method and the balance method. Okay, so let's find the answer. Which of the following is used for the determination of the particle size by gravity sedimentation? So because you can see the sedimentation word here, obviously it correlates with nothing but our Stokes law equation which we just discussed. So our Anderson pipette must be no other possibility, but the correct answer is going to be the Anderson pipette method. So option A here is definitely correct. Okay. Okay. Moving on. Total surface area of the powder is calculated by total surface area. We have seen for calculating the determining the surface area of the powder, we have multiple methods, right? We have seen the air permeability method, we have seen the adsorption method, in which we have gas adsorption method, we have solute adsorption method, right? So Anderson pipette, this is definitely a method we have already talked about, which is for this based on the sedimentation particle size determination. In the Coulter counter, we have seen it is for the particle volume measurement. So shear box, it is not applicable here. We are only left with the quite easy answer, sorptometer. Sorption, can you see the word sorption here? So here we adsorption methods we already seen the in the Quantasorb. So similar to that is the sorptometer. So we have correct answer as option number A. Okay, next. The type of the particle diameter that is obtained by the microscopic method of evaluation. So microscopic method of the evaluation based on, just like I have mentioned, suppose if you have this asymmetric particle, any asymmetric particle, you ultimately have to consider the particle to be in the shape of the approximate sphere. So we can use three diameters to characterize this particle. Number one with the projected diameter. Second will be the ferret's diameter. Third one is the Martin's diameter. Okay, so projected diameter is the diameter which is calculated from the most stable plane. The diameter of a particle having the same observed area as compared to the given particle in question, as well as the asymmetric particle, that is the considering particle as sphere and the asymmetric particle have a similar observed area, but when viewed from the most stable plane. So generally tangentially considered that it shows the most stable plane. So this is a projected diameter, right? Second, ferret's diameter. So ferret's diameter and Martin diameter, it is easy to remember as FTMB, FTMB, FTMB. So if I have to draw these two tangents across the particle, so ferret's diameter will be the distance between these two tangents. FT, ferret's diameter will be distance between the two tangents of the particle. So this is the ferret's diameter, right? That is why I have written here FT, ferret tangent. Next we have Martin diameter, MB, right? So Martin is the length of the line which is bisecting the particle. Length of the line which is bisecting the particle. Martin, bisecting. Length of the line which is bisecting the particle. Ferrets is the distance between two tangents. Third one was the projected. So here the question asks type of particle diameter obtained by microscopic method of evaluation. So concerned here is the projected diameter will be the correct answer. I hope it is very much clear to this relevant explanation. Okay. Okay. Next. In the Coulter counter method, now this you will do because I have explained the Coulter counter method already with quite a good explanation. I think you will be able to answer it. So Coulter counter method, as particles travel through the orifice, what events does actually occur? Which orifice? Just like I have mentioned, here you have a simple orifice through which this conducting particles from this conducting liquid will pass, and there will be change in dash that will be marked as a signal. So now you will be able to clearly tell me that ma'am, here it will be nothing but the change in the resistance, right? The resistance of the particle here, it will increase. This increase in the resistance will opt with the particle signal that will be noted down, right, and amplified, right? So here the resistance between the electrodes will increase. Option A is definitely correct. Okay, right. Option A, we have the right answer. Next, what is the unit of kinematic viscosity? Be it dynamic, be it kinematic viscosity, both of them have similar units, right? Similar SI units as well as CGS and other units. So here in this case, we have unit of kinematic viscosity as Stokes, dyne per centimeter, poise or gram per centimeter per second. So here mostly simple question here, Stokes will be the correct answer to this question. However, we have Pascal per second as well, and your Stokes, centi-Stokes, these units are also considered right as the CGS system. Next, which of the following is used for the determination of non-Newtonian fluid? So this is a simple classification I am telling you right now. This is a classification of viscometer. So we have two viscometer. One is the single point. Other one is the multi-point. Single point viscometer, other one is the multi-point viscometer. So single point viscometer is mainly for the Newtonian system. Single point viscometer is mainly for the Newtonian system. Multi-point is for Newtonian and non-Newtonian both. Multi-point is for Newtonian and non-Newtonian both. So single point viscometer, simple trick to remember is Foch. Simple trick to remember is Foch. This F is the falling sphere viscometer, right, of which the Hoppler viscometer is a type. I have written everything here only. For the Hoppler viscometer, type of falling sphere viscometer. O is the Oswald viscometer, which is a type of the capillary viscometer. Okay, so it is easy to remember this way, Foch. So everything is written here. Then for the multi-point, we have CCB, cup and bob, cone and plate, and Brookfield viscometer. So now it is quite easy for you all to answer. For single point viscometer, mainly for Newtonian system, we have Foch. For the multi-point, we have Newtonian, non-Newtonian both, CCB. So Brookfield viscometer, which of the following is used for the determination of a non-Newtonian system? So Brookfield comes under the multi-point, so it is for the non-Newtonian system. Oswald viscometer, Foch, it is for the single point, that means only Newtonian system. Creep viscometer is not applicable here, it is for the viscoelastic fluids we must consider. Then Anderson pipette, which is based on the sedimentation method. Okay, that is for the particle size determination. So I think we have our correct answer as option number A. Okay. Right. Next, which of the following apparatus is used for the viscoelastic properties of a non-Newtonian substance? See, just now I have told you, for specifically speaking of the viscoelastic, that means both viscosity as well as elasticity we need to consider. We have multiple models for it. We have Maxwell model, right? We have a Freud model, right? So in which the elasticity as well as the viscosity both are considered, right? For that mainly creep viscometers are used. As I've just mentioned, creep viscometers are used. Okay, Oswald viscometer we have seen is for mainly Newtonian system, Brookfield only for non-Newtonian, and Anderson pipette for the particle size determination. Okay, I think we have our correct answer, option number A. Okay, next question. A type of flow in which viscosity increases when the substance is agitated. So in the non-Newtonian system, we have certain system classified as time dependent and certain as time independent system. For the time dependent system, there will be restorative motion that will take place. For example, thixotropy, rheopectic systems, they are time dependent system. In the time independent system, we have plastic system, dilatant systems, and pseudoplastic system. The plastic systems, most importantly, they are known as the Bingham bodies. Plastic systems are known as Bingham bodies, which definitely require a certain yield value before they can start their rheological property. In none other than we do not require this yield value. For the rheopexy, I have told you this is a time dependent system. Okay, this is a time dependent system. Next, we have pseudoplastic system. These are known as shear thinning system. So it is an important topic to note that in the case of shear thinning system, the faster you stir, they are going to reduce in the viscosity. Faster you stir, agitation will be done. Example, in the case we have gums, mucilages, Traeger guns, Now they, as far as you stir them on a hot plate, they are going to lose their viscosity and will be more fluid in nature. So we have a pseudoplastic system where viscosity will decrease. But in the dilatant system, they are known to expand. They are known to dilate, expand in the volume. So these are known as shear thickening systems. Okay, so I hope my word here is clear that viscosity will increase in none other than our dilatant systems. Although in the plastic system also the viscosity increases, but if that was the question, there must be an additional option of yield value which is incomplete. So here we have our dilatant flow as the most precise answer. Okay, next question. Dilatant flow is also known as, see, just I have told you, dilatant flow is also known as, systems are known as shear thickening system. Shear thinning system were pseudoplastic system. Yield value required in the plastic system. 𝘎𝙎𝘾𝙐𝙎 is the time dependent system. Okay, so we have shear thickening system as our correct answer. Next, which of the following formulation will show plastic flow? Now, the plastic flow in which actually require a certain yield value after which they will show their property. So, I will give you a simple example of the flocculated particles. I will give you a simple example of the flocculated suspension. So, in this case, the particles are actually have small flocks, right? The particles have formed these flocks. These flocks are none other than our loose aggregates. So they require a certain shear force so that they just separate out, that is equal to the yield value, after which they will show their actual flow property, right? So here only the plastic system which have a flocculated particles which have the concentrated solid suspension, although if it is deflocculated, that will be included in the dilated system. Okay, highest percentage that will be included in the dilated system because they expand. Here just a yield value is required. So we have our simple example of concentrated solid suspension. Okay, next, pseudoplastic flow is exhibited by mucilages, gum, lotion, paste, emulsion. I have today only mentioned that pseudoplastic systems are none other than are shear thinning system. So shear thinning systems actually reduce in their viscosity once the agitation is done. So with the increase in the force, it will lose its viscosity and the viscosity will be reduced here. Shear thinning systems these are. So best example is gums, mucilages, carboxymethyl cellulose, we have tragaguns, sodium alginate, all these are considered in the pseudoplastic system. In the plastic systems, we have flocculated suspension. In the pseudoplastic, we have gums, mucilages. In the dilatant, we have our deflocculated systems. Okay. Next, in the case of plastic system, the apparent viscosity is below the yield value is. In the case of plastic system, apparent viscosity below the yield value is equal, lower, higher or infinite. So here first understand that the apparent viscosity will be equal to shear stress upon shear rate. Shear stress upon shear rate. Now here, because these are the plastic systems, which means they will not show their actual flowability till the point their yield value is not applied. So we can here clearly say that the shear rate here will be 0, right? So the apparent viscosity will turn out to be infinite because till the point their yield value is not reached, they will not show their rheological property. They are just going to behave as a solid only. So here the apparent viscosity will be actually 0, okay, because no flow will occur till the yield value is applied or yield stress is actually applied. So option D here is correct. Next, creep test is used to measure the viscoelastic properties of ointment, suspension, lotion or emulsion. So here, as mentioned before, the creep testing is mainly done for the viscoelastic models, right? So this creep testing will allow us to assess the viscosity as well as elasticity of the material. Now the emulsion, this is not a viscoelastic material. Similarly, lotion and suspension, these are also not the viscoelastic models, right? But the ointments are considered as the viscoelastic, right? So here, because of their semi-solid nature, so it is most evident that creep test will be used for the ointments also, not the suspension, lotion and emulsion. Okay, so that's it for today. We have reached the end of the MCQ series of today. So thank you so much. Keep watching our video. You can drop down your suggestions. We are damn working here for you all. We take your sincere your feedbacks also. So please keep on commenting. Please write down your responses, how much you scored with the questions, and that's how you evaluate yourself, and we have a good preparation going on. Thank you so much. We will meet in the next video.